Hello, algebra students. One last video here, unless I get some replies, so keep checking. I won't post any more after today. But I wanted to talk about multiplying rads, and I'm going to talk about the strange exponential graph. Anyway, rad 7 times rad 7, you guys should know by now, is rad 49. But 49 breaks down into a pair of dates, 7 times 7. So therefore it's 7. Now another way to think about it, even simpler, remember how I said when I multiply, I don't like to actually put them together if I don't have to. So look at that, I got a pair of 7s right there. Now they can go out on a date. The shortcut, of course, is to say that the two rads cancel each other out. So rad 7 times rad 7 is 7. Hey, what's rad 15 times rad 15? Well, of course, it's 15, right? Okay, now I'm going to use this idea as I come down here to multiply. Remember, doing a problem like 3 rad 3 times 5 rad 3 is a lot like multiplying 3x times 5x. I'm going to multiply coefficients and get 15. Now I'm going to multiply x times x. Okay, so 3 times 5 is 15. Rad 3 times rad 3, from what we just learned up above, is 3. So my answer is 45, because 3 times 15. There you go. Coming on over here, 6 rad 7 times 5 rad 7. I'm going to do 6 times 5 and get 30. Rad 7 times rad 7 is going to be 7. The answer is going to be 210. This is really simple stuff. No reason to get this wrong. Okay, 2 times 5 is 10. Now this one, you could say it's rad 18, but I don't like to do that. I like to say it's 6 times 3, because I know there's a 3 hiding in here. And look at that, I have a pair of dates. So now out front I've got a 10. The 3's came out on one date, and the 2's left home alone washing his hair. Now, of course, the best answer would be 30 rad 2. There you go. I know I'm going a little fast, but this should be easy stuff. A problem like this is a FOIL problem. So I'm going to do my firsts. And that would be 2 times 5. Then I'm going to do my outers, which would be 2 times 2 rad 3. Well, that's going to be 4 rad 3, because I multiply the 2 times the 2, and then there's nothing to multiply with the rad 3. All right, my inners, I forgot to put a plus sign there. My inners are going to be negative 4 rad 3 times 5. Well, that's going to be a negative 20 rad 3. And then finally, my lasts will be negative 8 times 3, or better yet, negative 24. Because 2 times 2 is, wait a minute, negative 4 times 2 is negative 8. Rad 3 times rad 3 is 3. So I get a negative 24. Now I'm going to combine my like terms. All right, so I've got a 10 and a negative 24. And I also have a positive 4 rad 3 and a negative 20 rad 3. So I'm going to get a negative 14 from the yellow ones. And from the green ones, I'm going to get a negative 16 rad 3, right? 4 minus 20, negative 16. There you go. All right, coming down here, we're going to do 10 times 5. Well, that's 50. Okay. And the outers is going to be 20 rad 10. The inners are going to be negative 25 rad 2. Then the lasts, we're going to get a negative 10, a negative 10, but then under the rad, we're going to have 2 times 10, and that's going to break down into 2 times 5. And look at that. Oop, that doesn't look like a 5, sorry. 2 times 5, and there is a date. So this is really going to be 20 rad 5 for this last one. I still have to combine like terms. I've got a feeling I'm not going to have quite as many like terms in this one. I've got a 50, right? Ooh, I don't see any like terms. Yeah, but I'm glad I checked, but I don't see any. I'm going to go through and make sure I didn't make any mistakes multiplying. There's 50. Outers would be 20 rad 10, positive. Inners would be negative 25 rad 2. And then we're going to get a 10 rad 5, I believe. 20 rad 5, right? Because I have to pull the 2 out. Yeah, so there are no like terms here. So my answer is 50 plus 20 rad 10 minus 25 rad 2 minus 20 rad 5. Now, some of you on the last test we took were combining these guys, but they're not like terms. That's like adding 20x minus 25y minus 20z, because all the rads are different. In multiplication, you don't need like terms. In addition and subtraction, you do. All right, so come down here. Another FOIL problem. Cross that out and rewrite it as 6 plus 2 rad 3. All right, so my firsts are going to get me 36, right? My outers are going to give me 12 rad 3. My inners are going to get me 12 rad 3. Then my last, 2 times 2 is 4, but rad 3 times rad 3 is 3. So I'm going to have 4 times 3, or 12. All right, now this one does have like terms. Looks like I'm going to have a 48 from the 36 and the 12. And then how many rad 3s do I have? Looks like I have 24 rad 3s. Okay, I'm not going to do any more on that. You can go back and watch that video. Somebody talked about purplemath.com being a good place to look stuff up. You know, you can watch Khan Academy videos, whatever it takes for you to get it right. That's the important thing. All right, now, there's been a lot of talk about problems like this. Remember, order of operations. Order of operations. Order of operations. It's super duper important. I'm still going to go ahead and make my input-output table. I'm still going to identify my asymptote. In this problem, the asymptote is 0, right? Y equals 0, because there's nothing being added out here. So the asymptote is y equals 0. It's the x-axis. And so I can put a broken line there. Okay. Now, excuse me. All right, so what values do I put in? Well, I like my exponent to be 0. That's the first value I want to put in. What number turns this variable to 0? Well, 0, of course. If it looked like this, y equals 3 to say x minus 5, the first value I'd put in my input-output table would be a 5, because that would turn this to 0. Okay? All right, so I put 0 in, and I get 2 to the 0, which is 1, times 3 is 3. Now I can do 1 and 2, and negative 1 and negative 2, and see what happens. So 2 to the first is 2, times 3 is 6. 2 to the second is 4. 4 times 3 is 12. Okay, so I'm going to have 0, 1, 2, 3 right here. 1's going to be at 4, 5, 6. And then 2, 12 is going to be like right up there. Okay, negative first. Negative first. 2 to the negative first is 1/2. 3 times 1/2 is 3/2, or better yet, 1 1/2. Okay, negative 1. There we go, 1 1/2. All right. Negative 2. Negative 2. Yeah, I did that right. I had a feeling I did that wrong. That's why I paused for a second. All right. Negative 2 is going to give me 1/4. So this is going to be 3/4. Okay, so negative 2 is going to be at 3/4. Now, it's not really that close to the asymptote. I'll tell you what. Let's extend our table a little bit. Let's do a couple more values. Oops, move out of my way, asymptote equation. All right, and I'm going to do just a couple more, just so you can see that it is going to behave just like all the other ones we've done. And I'm thinking just 3 more will be good. I'll do negative 3, negative 4, and negative 5. All right, so 2 to the negative third is 1/8, so this becomes 3/8. 2 to the negative fourth is 1/16, so this is 3/16. And see how these fractions are getting smaller and smaller? I believe this one's going to be 3 over 32, 3/32. And there you go. It's going to get smaller and smaller and smaller. And so the shape is still going to be the familiar quarter pipe. Right? Just like that. Okay, that's it for the video. Mr. Lawrence signing off. Actually, you know what? I'm going to post one more video on Monday night. And I know the final will be over. Please make sure you watch it because our time is going to be so crunched in class. I don't get to see you in class on Monday. Tuesday, we're going to be doing some things. Please make sure you watch the video. Thanks a lot. Good night, everybody.